Problem set number 6 is no joke. These look about the same as the other 5 groups of problems, but they are getting harder. I want to remind you as we write our first one here that just because it comes in a cute package does not mean that it's actually easy. This one's actually a lot of work. So let's look at why that might be. If I want to find the derivative of this, I want to remind you that if I have a function that's to the x power, you want to remember that if you have something that's a to the x like that, you can rewrite it as e to the ln of a to the x like that. And the reason we do that is because you can bring the exponent out, and it would make e to the x ln of a. And now you have a constant here instead of some ugly function. That's going to matter. It's going to matter a lot. So keep that in mind as we do this problem here. So we want to write it as y equals e to the ln of 3 to the x ln of x. Now you see how I brought this whole thing in here. So remember, e to the natural log of anything is that anything. It's the same statement as just making the original. We haven't done any manipulation or derivative work yet at all, but we can bring this whole exponent in front here. So we get e to the ln of 3 times x ln of x like that. That's getting us one step closer. I hope you remember that chapter section. Of course, there's explainers and problem examples in this playlist. This is definitely on a calc final, so be ready. Now, what are we going to do with that? Well, we're going to have to take a derivative. I don't see how we could get around that. So how would I take a derivative of this? Well, y prime is going to be the original input. The derivative of e to the x is still e to the x, even ugly like this. So ln of 3 times x ln of x, that stays the same, but now comes the chain rule part where it all comes out. And what do we know? Well, we need the derivative of this. Now, of course, there's a double x function here, so that's going to be a product rule, isn't it? We can pull the ln of 3 out. Because it's just a constant. And it's going to be multiplied by our product rule, u prime v plus v prime u. And that's our x ln of x here. So u prime is going to be 1. V is ln of x. V prime is 1 over x. Thank God for that. And u is x. This might not be so ugly now that we've worked it out. So we're going to get, on this step, e to the ln 3 times x ln of x. I apologize about the ping there. Highly inappropriate. Ln of 3. And this is ln of x plus 1. How many of you checked your phone because of that noise? I'm so sorry about that. I hate when people do that in videos. I will try to be more careful about that. Now, where are we at here? Well, we can kind of replace this back in because we know what it is. E to the x ln x, kind of looked weird, ln of x ln of 3 is the original 3 to the x ln of x. Remember? So we'll put that in, 3 to the x ln of x. That's just right here from the very beginning when we rewrote it. So I undid that for the sake of simplification at the end here for our y prime still. And then we have this nightmare to go with it, which is ln of 3 times ln of x plus 1. And if you can factor it in this way, you are rolling. So there's a few things here that can really bog down a student. One of them is, of course, the initial replacement. But doing the product rule here as your chain rule, make sure that you pull constants out just to keep them out of the way. It's nice to have that. And then be able to take this, put this back up into the exponent and get rid of the e to the ln stuff. It's super important that you can do that. Okay, problem number 2. This problem might be easier than it looks. Let's find out. So of course that would be the same as 1 over 1 minus 1 over x. And we definitely can simplify this. If I want to put this all in terms of x, the first thing I would write it is as 1 over x minus 1 over x, so that I could write it as 1 over x minus 1 over x. And just to make them all into fractions, I'll try and make it clear here. That's the same as multiplying by the reciprocal. So we can say it's 1 over 1 times x over x minus 1, which of course means y just equals x over x minus 1. Now how do I take the derivative of this? It's less scary. Well, there's an x function divided by an x function. That's a quotient rule. Q for quotient rule. So let's do it. Y prime equals u prime v minus v prime u over v squared. You should be so tired of that now, but it's exciting, isn't it exciting? U prime is going to be 1, v is going to be x minus 1, minus v prime. Well, that's still just 1, and then u is x, divided by v squared, so it'll be x minus 1 squared. So what do we got here? We have x minus 1 minus x, so those are just gone. And we're just going to get negative 1 over x minus 1 squared. How beautiful is that? That's not so bad. That's not so bad. What about the next problem? Problem number 3. This one has a couple of y's, so it should be immediately apparent that this is going to be implicit differentiation. Anytime you have more than one y, you're going to be doing implicit. So let's take the derivative with respect to x. This should be fun. I love implicit. It's not hard. You just got to do it step by step. What's the derivative of the outside function? That's just sine. So we're going to get what we can't even write y equals because it's not. Cosine of xy times chain rule. U prime is 1, v is y, plus v prime, that's dy dx, that's what we're looking for, times u, which is x, equals 2x minus dy dx. That's not that bad. It's really not that bad. So we get y cosine xy. See, we don't really care. We just need to know how to do the steps. Plus dy dx x cosine xy plus dy dx equals 2x. I moved that over at the same time. Let's move the other one over. So we would get dy dx x cosine xy plus 1 equals 2x minus y cosine xy. Did a couple steps there, right? I factored these together and I moved this one over. Now we just divide. Dy dx equals 2x minus y cosine of xy divided by x cosine xy plus 1. What do you think? You want to go looking for a simpler answer? Should we try and change this around? I think we'll just leave it like that. Okay, that is the correct answer. Let's look for problem number 4. Well, obviously when I have a y equals log base 5, they're asking you to remember a rule. And you need to know this rule. I always forget this rule, but Important thing to remember is that you have a log base, I guess we'll call it 5 of x in this case, just to keep it simple. That's going to be the same as saying ln of x divided by ln of the base. So just remember the base goes on bottom. That's how I remember it. Base on bottom, input on top. Now, how do we change this here? Well, we would say y equals ln of 1 plus 2x divided by ln of 5. Now we have a simple quotient rule. You don't actually need a function of x on both sides to use a quotient rule. It's not actually that hard. But it might be easier to write it as just 1 over ln of 5 and then take it out of this and think of this as its own separate derivative to do. What the heck did I write there? ln of 1 plus 2x, because that will still work. That will still work. So we only really need to take the derivative of the function of x itself. The scale can just come out. So what is the derivative of that? Let's just take the derivative of that on its own. It's going to be 1 over the input, 1 plus 2x, times chain rule. What's the derivative of the inside function? Right here. That's just 2. So what we're going to end up with for y prime is 2 over ln of 5 times 1 over 1 plus 2x. So we would get 2 divided by ln of 5, 1 plus 2x, like so. And that's really all you need for this final answer. That's the correct answer. And it concludes problem set number 6. That wasn't so bad. Let's do number 7.